So today we're going to be turning to page 64 and 65 in our packet. It is section 8.2.1, how can I find the equation? We covered a little bit of this the other day in our notes. We're going to take a look at two different types of equations. One that's linear equations, lines, and the other is exponential equations that we covered the other day. So we're going to take a look at this first problem, 8-92. Mitchell was helping his friend work on his algebra homework. They were trying to write the equation of the line that passes through the points 5, 15 and 3, 7. Suddenly Mitchell had an idea about finding linear equations. Look, he explained, we know that the line can be written in the form y equal mx plus b. And we also know that the points 5, 15 and 3, 7 have to make the equation true. So we can substitute these 2 points into to create a system of equations. When we solve that, we'll know the values of m and b, and we'll have our equation. Part A says, what is Mitchell talking about? Use this method to write the equation of a line through the points 5, 15 and 3, 7. So what we're going to do is we're going to take y equal mx plus b, and we are going to be writing two equations. One for the point 5, 15, putting 5 in for the x and 15 in for the y. And then a second equation using 3, 7, putting 3 in for the x and 7 in for the y. So I'm going to first start with 5, 15, and I'm going to be substituting the 15 in for the y. So I'm going to put 15 is equal to, and I'm going to be putting the 5 in here. So when I put the 5 in here, it's going to be 5 times m. So I'm going to get 5m plus b. That's our first equation. The second equation is going to come from 3, 7. And I'm going to do the same thing. I'm going to put 7 in for the y. So I'm going to get 7 is equal to. I'm going to put 3 in for the x. So I'm going to get 3 times m plus b. And now I have the system of equations. Now every time I have this with lines, I am going to get a plus b and a plus b, so I can easily use elimination. So what I'm going to do is I'm going to rewrite it down here, and I'm going to be trying to get my b's to cancel out. So I'm going to multiply the second equation by a -1. So let me just rewrite that. 15 is equal to 5m plus b, and 7 is equal to 3m plus b. And again, I'm going to be multiplying this by a negative. So here, the top one I'm going to keep, 5m plus b. I'm deciding to make the second one negative, so it's going to become a -7 is equal to a -3m minus b. And now I can take those two equations and I can add that using elimination. My b's are going to cancel out. So 15 and a -7 give me an 8. 5m minus 3m, that gives me a 2m. And then again, my b's are going to cancel out. And so I'm left with 8 is equal to 2m. So now I'm going to solve for m. I'm going to divide by 2, and I get m is equal to 4. So right now I know my m. So I know it's going to be y is equal to 4x plus b. So now I need to find my b. So I can substitute that into either of these two equations. Let's say I do it to the bottom one here. So let's say I do it into the 7 is equal to 3m plus b. So I'm going to put my 4 in place of my m. So 3 times 4 plus b. So now I get 7 is equal to 12 plus b. And now I'm going to subtract 12 from both sides. And I get -5 is equal to b. So now I know my m is 4 and I know my b is -5. So I know my equation is going to be y equal, again, mx plus b. So y equals, in place of my m, I'm going to get 4x, and in place of my b, I'm going to get a -5. And that is our equation. So now we're going to do the same thing for the next one. So for the next one, same idea. Again, it's going to be a line. So for this one, use Mitchell's method from problem 8-92 to write the equation of the line that passes through the points 2, 3 and 5, -6. So you set this up and try this, and then you can pause the video, and then we can restart it and see if you got the right answer. So I'm going to be taking 2, 3 and 5, -6, and I again am going to be substituting it because again it is a line, so y equal mx plus b. So I'm going to be putting the 3 in place of the y, the 2 in place of my x, so that's going to give me a 2m and then a plus b. And I'm going to do the same with this one. So I'm going to get -6 is equal to, because again that's my y, and then my 5 is going to go in for my x, so I'm going to get 5 times m plus b. And again what's going to happen is I get a b and a b, so again I can easily use elimination. So let me take the top one this time, and I'm going to multiply the top one by a negative. It doesn't matter which one I do. I just am choosing to do the top one. Okay, so when I multiply that top one by a negative, I get a -3 is equal to a -2m minus b. And this one I'm just going to rewrite. -6 is equal to 5m plus b. And again, my b's are going to be able to cancel out. So when I add that, -3 and a -6 make a -9 is equal to 3m when I do that math, and my b's are going to cancel out. So now I'm going to solve this. I'm going to divide both sides by 3, and I get m is equal to -3. So I know my m. So now I'm going to take this m and plug it either into the top equation here or the second equation. Doesn't matter. I think I'm going to do it into the top equation. So I'm going to take this and I'm going to be substituting it in to the second equation. I'm just going to do my math over here. So I am going to be getting 3 equal 2 times my m. Okay, so I'm doing it into this equation, and my m is -3 plus b. And so now, when I do that math, I get 3 is equal to -6 plus b. And I'm going to solve for b, so I'm going to add 6 to both sides. And so I add 6 here, I add 6 here, and I get 9 is equal to b. So I know my m and I know my b. So now my equation is going to be y equal mx plus b, because again it is a line, and in place of my m I'm going to put a -3, and in place of my b I'm going to put a 9. So I get y is equal to -3x plus 9, and that's going to be my equation. So now on the next page, page 65, let me flip it over. This time we're going to be doing a similar idea, but it's not with a line, it's with an exponential. So it says on 8-94, Mitchell thought that maybe his method from problem 8-92 could be used to write equations of exponential functions. Mitchell wondered if he could write the equation of the exponential function that passed through the points 2, 144 and 6, 729. The first question here says, what is the general form for an exponential function that has an asymptote at y equals 0? Those are the only type that we have dealt with. Okay, so our equation for all exponentials with an asymptote at y equals 0 is y equal a times b to the power x. Okay, all of our equations of exponentials are going to be y equal a, which is our start, our 0, times b, which is our multiplier to the power x. So this is kind of like the notes we did the other day. We're going to be substituting in 2, 144 in for the x and y and get one equation, and 6, 729 into the x and y and get a second equation. So 2, 144, and I'm going to substitute them in here. So I'm going to get 144 is equal to a times b to the power x, which in this case is a 2. I'm going to take the second point, 6, 729, and I'm going to do 729, which is my y, is equal to a times b to the power x, and again, this time the x is a 6. So I end up with these two equations. Now the other day, what we did was we tried to get one of these equations to be a equal. A equal is easier than trying to get it to be b equal because of the powers. And what we said the other day was it's easier to do it with the one that has the smallest exponent. So this is the one that has a smaller exponent. So this one is the one I'm going to get in the form a equal. So let me just rewrite it here. 144 is equal to a times b to the power 2. And again, I'm trying to get this to be a equal, so I'm trying to get my a by itself. So to get my a by itself, I'm going to divide both sides by b squared. And then when I do that, I end up getting this equation. I get 144 over b squared is equal to a. This isn't my answer, but this is what I'm going to be substituting into a in my other equation. So again, I rewrote this for a. So now, into a in my other equation, I am going to be substituting that in. So right here where I have my a, this 144 over b squared is going to go in place of that a. So now I'm going to take this equation, I'm going to rewrite it, and so I'm going to take 729 is equal to, and in place of my a, I'm going to put 144 b squared times b to the 6th. Okay, again, this 144 over b squared was my a. Okay, so I put it in place of a in this equation. So now when I clean this up, I'm going to have 729 is equal to 144, and in this case I have b to the 2nd on bottom, I have b to the 6th on top. So I can cancel 2 on the bottom with 2 on the top, leaving me with a b to the 4th on top. Now I'm going to solve this equation. So to solve this equation, I'm going to try to get my b to the 4th by itself. I'm going to divide both sides by 144. And so I'm going to take 729 divided by 144, and I end up getting this decimal, 5.0625. So let me just write it down here. 5.0625 is equal to b to the 4th. So now, in order to get my b by itself, I'm going to take the 4th root of both sides. So I'm going to take the 4th root of 5.0625, and when I take the 4th root of b to the 4th, I get b. So now I'm going to put this in my calculator. So I'm going to do the 4th root of 5.0625, and I'm going to get a 1.5. So I have 1.5 is equal to b. So right now I know my b. My b is equal to 1.5, and I need to now find my a. So to find my a, again, I'm just going to keep going down because B and C are asking us to go through and solve this, so we're going through and solving it. So to find my A, the easiest way is to use this equation, because I know this one is A equal. So I can put my 1.5 in here for my B. So I'm going to get 144 over B squared, and B is 1.5, so I'm going to have 1.5 squared is equal to A. And then I'm going to put that in my calculator. So I'm going to take 144 divided by 1.5 squared, and I end up getting 64. So my A is 64. So 64 equals A. So now that I have my A and my B, I can write my equation. So my equation is going to be y equal, again, A times B to the power x. So y equals my A, which is 64, times my B, which is 1.5, to the power x. So now, you guys are going to try on 8-95, A and B using the same method I just used here. So again, you can pause the video, try A, play it back, see my answer. So let me go with the answer right now. So I'm going to go through the same method. I'm going to go for -1, -2. I'm going to get -2 is equal to A times B to the negative first power. Again, this is my y and this is my x. I'm going to do the same with, sorry, I'm writing that point wrong, 3 comma -162. So I'm going to get -162 is equal to A times B to the third. Now that we have these two, what you want to do is you want to solve one of them for A. The one with the smallest exponent is easiest. This is the one with the smallest exponent. So I'm going to do that down here. So when I get this to be A equal, I'm going to divide this side by B to the -1, and I'm going to divide this side by B to the -1. So I'm going to get -2 over B to the -1 is equal to A. Okay, so that's that equation, just written in A form, A equal. So now I'm going to take that A, and I'm going to substitute it into this equation. So into this equation for A, I'm going to put -2 B to the -1st. That's what I'm going to put in. So I'm going to now take my -162 is equal to, and my A is this, -2 over B to the -1 times B to the third. Now, the nice thing about this is this B to the -1, we don't like that B to the -1, so we're actually going to move it up here to the top. So when I do that, I'm going to get -162 is equal to -2 times B to the third times B to the first. Again, it was a negative on bottom, so when I move it to the top, it's now going to be a positive. So I'm going to get a -162 is equal to -2 B to the fourth. I'm going to now try to solve for B. I'm going to divide both sides by -2. And when I divide both sides by -2, -162 divided by -2 is going to be an 81 is equal to B to the fourth. Then I'm going to take the fourth root of both sides. I'm going to take the fourth root of 81 and the fourth root of B to the fourth, which is B. Now, when I put this into my calculator and I take the fourth root of 81, the fourth root of 81, I'm going to get 3. So this is going to be 3 is equal to b. So I know my b is equal to 3. So now I can take this and I can substitute it into this equation. Okay, so now I'm going to substitute it into that. So it's -2, and again, the b to the negative first, if I move that up, it really becomes b, or b to the first. So really this and this are the same. This is the nicer version, is equal to a. So I'm going to have -2 times 3 is equal to a. So a is equal to -6. So now I can write my equation. So I'm going to get y is equal to my a, which is -6, times my b, which is 3, to the power x. And that is going to be my equation. So now if you want to pause the video and try b on your own. Okay. Okay, so now let's go over b. And let me just draw a line here to separate these two. So what I'm going to do again is I'm going to substitute these in. So 2 comma 1.75 is going to give me 1.75 is equal to a times b to the power x, which is 2. For the second equation, I'm going to use -2 comma 28. So my y is going to be 28 is equal to a times b to the -2nd. So again, we like to solve the equation for a that has the smaller exponent. The -2 would be the smaller exponent. So I'm going to rewrite this in terms of a. So I'm going to be dividing both sides by b to the -2nd. So 28 is equal to a times b to the -2nd. I'm going to divide this by b to the -2nd. I'm going to divide this by b to the -2nd. And I get a is equal to 28 over b to the -2nd. Now, I didn't rewrite it right away in the last example, but you can rewrite this because we do not like b being raised to a negative power. So if it's negative on bottom, I can move it to the top. So really, this is 28. B to the second is equal to a. And that might be a little easier to use. So in place of my a, in my top equation, I'm going to be substituting this in place of the a. I'm always doing it into the equation I did not use. Okay, so now I'm going to take 1.75 is equal, and in place of my a, I'm going to put 28b squared times b squared. And now I get 1.75 is equal to 28b to the 4th. And now I'm going to solve this for b. So to solve for b, I'm going to divide both sides by 28. And when I do that on my calculator, 1.75, let me move it over here. 1.75 divided by 28, I get 0.0625. So 0.0625 is equal to b to the 4th. And I don't want to round it because if I do, sometimes I'm going to ruin what might be a nice answer, and I think this one's going to be a nice answer. So the next thing I'm going to do is I'm going to take the 4th root of both sides. So the 4th root of 0.0625, and the 4th root of b to the 4th is b. So now I'm going to do the 4th root of 0.0625, and I get 0.5. So 0.5 is equal to b. So now I can take this 0.5 and I can substitute it into my equation that was a equal to find my a. So, and actually this one here is the nicer one. I should do it here because this one I already changed it to be the second. So now, let's do it into this one right here. This is the one I'm going to substitute it into. So I'm going to take 28 times b to the second, which is 0.5 squared, and that's going to be a. So now, let me do that on my calculator. So I'm going to get 28 times 0.5 squared, and I end up with 7. And that is my a. So now I can write my equation. Y is equal to a, which is 7, times my b, which is 0.5 to the power x. And that is going to be my equation. So make sure that you get this down in your on your paper and submit it through Google Classroom. Bye.